Let me start off by giving a very warm welcome to all of our friends of Gladstone who've joined on today. My name is Deepak Srivastava. My name is Deepak Srivastava, and I'm the president of the Gladstone Institutes. And we are very fortunate here at Gladstone to have some of the world's leading virologists here on our staff that have really stepped up incredibly over the last year and a half to lead what's now nearly half of our investigators at Gladstone to be working on COVID-19. And they have been able to do so both through the study of the virus itself, but because the virus affects the heart, the brain, and the immune system, it's really been an all-hands effort here at Gladstone tackling this pandemic. We had scheduled this public forum weeks ago in anticipation of our turning the page to 2022 and really doing this as a public service for you all in our orbit to share, what we might expect for 2022. Of course, over the last 7 to 10 days, everything has changed a bit with the emergence of this new Omicron variant that I'm sure all of you have been reading about. And so we thought today we'll have some discussion about where we are with the pandemic in general. And it's important to note that Delta is still the dominant form that is affecting us. And it has, as we anticipate even before Omicron, is leading to a winter surge that we will have here in the United States and really all over the world. So we'll have a chance to talk about where we are in the pandemic, the Omicron variant, and some of the work we're doing at Gladstone, and then answer any questions you all might have as we enter 2022. So we're very fortunate today to have Dr. Melanie Ott, who's the director of our Institute of Virology with us, and also Dr. Warner Green, who is the director of the Michael Holton Center for HIV Cures Research and was the founding director of the Institute of Virology and Immunology here at Gladstone. And we'll lead off with Dr. Green sharing a few thoughts and even some slides about where we are. And Dr. Ott will follow that with a few comments. And then please put in any questions you might have into the Q&A button at the bottom of your screen. And we'll spend some time just having a discussion together and answering anything that might be on your mind. So with that, Warner, I'll turn it over to you.
Thank you, Deepak. I'll share my screen. Okay, so let's begin. Thank you everyone for attending. Yes, we've been thrown a curveball called Omicron, but as Deepak mentioned, right now Europe is being very hard hit and it's all being driven by the Delta variant. United States also, we're increasing in our infections, also driven by Delta. But of course, the news is of this new Omicron variant coming out of Southern Africa, specifically Botswana and South Africa. At least that's where it was detected first. And now appears to be spreading around the world. What is unclear at this point in time, though, is how effectively will Omicron be able to do battle with Delta on an even keel, or even trying to pry its way into an environment that's 99.9% Delta. In South Africa, Delta was way on the wane. And so Omicron had open field to run in, basically. So we still have to see how Omicron and Delta do when they're in a pitched battle with each other. Several things are happening along with Delta and Omicron. Austria has become the first country to order a lockdown only of unvaccinated people and will mandate by February 1st vaccination of all eligible citizens. Germany is expected to follow suit and likely to approve a similar vaccine mandate in their Bundestag. England and Hungary are requiring health and social workers to be vaccinated by April 1st. Sweden has no mandatory vaccination, but a COVID pass for entry. And similarly, France has vaccination requirements for certain groups and a health pass for entry. Switzerland, no mandatory vaccination, but health passes. So you see, Europe is responding in different ways, but more and more we're seeing mandates, we're seeing restrictions on unvaccinated individuals and at least a discussion now of vaccine mandates for all citizens. That brings up the issue of COVID vaccinations. This is a summary of the current status of vaccination. You see that, in fact, this huge kind of very pale spot in sub-Saharan Africa. And in fact, until this is a global problem, until we have control of this virus throughout the globe, we can anticipate the spinoff of variants like Delta, which came out of the India surge, and likely Omicron, which likely came out of Southern Africa. The United States now is over 60% vaccinated, cleared that mark, but like over 85% fully vaccinated for their over 65 population. But still, we trail many countries in the world in terms of getting our populace vaccinated. There have been an uptick in these vaccinations with the emergence of Delta, and even more so now with the reports about Omicron. The World Health Organization describes the disparity in COVID vaccine access as a scandal that must stop now, noting that 6 times more booster shots are being administered globally than primary doses in low-income countries. This is really talking about sub-Saharan Africa, which of course is highly relevant to the situation that has potentially allowed the emergence of the Omicron variant. Here in the United States, the virus is moving north and east. You can see this across the Rust Belt. You can see actually penetration of this virus now into New England. These are highly vaccinated parts of the country. Contrast this with where the virus was. You can only look at hospitalization. It was in the Mountain West and started up toward the north, but now it's really moving strongly north and eastward in the United States. California is doing well, although now infections are increasing a bit. The hospitalizations, however, are not really increasing, and deaths are down. Here in the Bay Area, we're doing particularly well. 4 out of the 5 counties in the Bay Area are amongst the lowest, have the lowest case rates in the entire state. So let's turn to Omicron. Omicron was first described November 25th by scientists at the Botswana Harvard HIV Reference Laboratory in Gaborone, and nearly simultaneously by South African scientists working in the Gauteng province. This is Pretoria, this is the Johannesburg area. The first cluster was amongst the college students. It was declared a variant of concern by the WHO in record time, within 24 hours, because of the mutations it contains, suggesting high infectivity and immune evasion. This has now spread to at least 38 countries. This number changes daily. It's probably over 40, maybe over 50 countries today. This is a picture of some of the places on December 2nd that the virus had migrated to. This is, in fact, the Gauteng province. This is the most populated area of South Africa. And this is where the initial infection cluster emerged. There are now early clinical reports out of the hospitals in Gauteng that are emerging. And they are encouraging, but they are very small in scope. For example, some of the data are that the patients are being admitted to the hospital, but they are admitted for a much briefer period of time. The patients being admitted are not requiring supplemental oxygen. They are doing well on room air, by and large. There have been, and so it would appear most of these individuals are unvaccinated, although there have been vaccinated admissions as well. The sense of this early report out of one district within Gauteng is that it looks to be a highly infectious virus, but it may not be as virulent or as pathogenic as the Delta variant. So that I caution that this is very early days, and one needs far greater data, more robust data sets to make any firm conclusions. This variant contains more than 50 mutations that have been seen in combination before. And importantly, it contains 32 different mutations within the spike protein. Of course, it's the spike protein where the vaccines are eliciting the neutralizing antibody response, and precisely where those neutralizing antibodies bind, there are a bunch of mutations. And so if you look at the spike protein, you see, in fact, 15 mutations up here in the right upper corner that are in the receptor binding domain. That's where a lot of the neutralizing antibodies bind. And you can read and see that, in fact, there are mutations all over the spike protein, including a group of 4 mutations, a group of 2 deletions that destroy the ability of the PCR test to detect the presence of the spike. And this has turned out to be, from an epidemiological point of view, a very valuable finding, in that you can trace the movement of this virus in a population by the absence of the spike signal in the PCR reaction. The same was true of the Alpha variant early in that, when it was spreading around the world. 3 mutations occur in the furin cleavage site. This greatly improves the infectivity of this virus. And as I was mentioning, it appears that this virus is able to spread more effectively than Delta. That's the early conclusion. So rapid information sharing by the South Africans about Omicron, they were rewarded by a multi-country travel ban. And such bans, as we have seen already with the spread of the virus around the world, are routinely too little and too late. The one thing that might have worked is a complete shutdown of all traffic into a country, like as Israel has done. That, because you don't know where the virus has spread to, and so you basically have to lock out everyone. But even that approach is short-sighted, because, as we know, Israel already has infections within its own borders. So let's talk about a few relevant facts in terms of the Omicron variant. Infections in the Gauteng province of South Africa are doubling every 2 to 3 days. It's clearly at least 75% of the new infections are due to Omicron, probably a higher rate than that now. As I mentioned, Delta is fading in South Africa, and so Omicron is climbing up and taking over as Delta is fading away. There are essentially Omicron did not have to push Delta out. The rise in cases in South Africa has also been accompanied by week-over-week increase in hospital admissions, mainly in the unvaccinated. And so the hospitals are not threatened. They're not being overwhelmed, but numbers are going up. But as I mentioned, they often stay longer. They don't require oxygen. They're doing, by and large, better than certainly was the case in prior waves of infection. So this is data from the South Africa National Institute for Communicable Disease. We see the increase in red of the Omicron wave, the very beginning, comparing that to the beta, the Delta, first wave beta and Delta. It's a more rapid rise. But you look at weekly hospital admissions, it's not that is not on a more rapid rise, at least at this early point in time. But we need to see a greater completion of these curves to fully understand where things are going. Interestingly, levels of coronavirus in the wastewater in Gauteng province, if you looked back in mid-November or late November, late October and early November, you saw, in fact, coronaviruses going up in the wastewater. This was a sign, and the levels of this are almost at the peak that it was achieved at the top of the Delta wave. So in fact, this is a very helpful approach in terms of screening the wastewater as an early canary in the coal mine, if you will, detection of coronavirus beginning to spread within a community. South Africa is only 25% fully vaccinated. That's a heck of a lot better than most of sub-Saharan Africa, which is around 7% fully vaccinated. And as we talked about, the vaccine equity issue is being emphasized as one potential contributor to the appearance of Omicron. Infection-acquired immunity is thought to be quite high in South Africa. So while they're not heavily vaccinated, a lot of people in South Africa have been infected with the virus as a part of these wave after wave after wave of coronavirus. And indeed, they're seeing an uptick in reinfections among people who tested positive for the virus at least 90 days earlier, suggesting that the immunity acquired through natural infection is not as active against Omicron. That goes along with the immunoevasive mutations, which are included within that compendium of 32 spike mutations. A preliminary study suggests that Omicron is 3 times more likely to cause reinfection compared to the Delta and the Beta strains. More than half of those infected with the Omicron coronavirus in England have been double jabbed. In other words, they would be by definition fully vaccinated. Very small numbers, but in fact, it emphasizes and we don't know exactly when they got their double jab, whether they're at the end of the 6 months with declining antibody levels, and thus are more susceptible to any of the coronaviruses. We don't know those facts yet, but clearly, I think the best protection that one can take at this point in time against Omicron, as well as the predominant Delta, is to be boosted if you're at 6 months or later from your initial dual vaccination. So the Omicron variant of concern, concerns and reassuring findings. Concerns, the rapid spread. Omicron likely infects 2 to 3 times more people than Delta. So if Delta infected 6, it's likely that Omicron might infect 8 to 9. Dizzying array of old and new mutations linked with improved infection and immune evasion. Natural immunity from prior infection, not fully protective. Of course, this was very reminiscent of the Beta and Gamma variants that we talked about arising in South Africa and in South America. Those viruses never took off because they didn't have the high transmissibility of Delta, for example. Delta crowded them all out. But this virus comes with both barrels loaded, high infectivity, and potentially the ability for immunoevasion. But maybe what it's lacking is pathogenicity. Natural immunity from prior infection is not fully protective, and mutations match those present in viruses selected in the laboratory for resistance, high level resistance to neutralizing antibodies. The reassuring findings are cases are primarily occurring in the unvaccinated, but data is quite limited. And as I mentioned, some patients in the hospital in Gauteng are, in fact, had been vaccinated. No Omicron deaths yet recorded, but that is early. And in fact, in the study published today out of Gauteng, there have been 10 deaths. Individuals tend to have milder disease, shortened stay in the hospital, require less oxygen, all good signs. If needed, new Omicron-specific RNA vaccines are said to be able to be produced within 100 days and could be deployed, assuming rapid regulatory approval, quite rapidly without large-scale additional clinical testing. The key question, how effective will our vaccines be, our vaccines with the booster? Is Omicron equally pathogenic to Delta, or is it much less pathogenic because of its multiple mutations? Is it an attenuated virus? It would be a great thing if, in fact, Omicron crowded out Delta, and if Omicron was a less pathogenic virus. That would be very good for the human race. We would be dealing with a less pathogenic virus. And there's simply an underscore that these are early days. Things are changing on a daily basis. Information is starting to flow. It's going to take a month or so for us to really get an idea about the pathogenicity of this virus, its effectiveness against Delta in an equal or in a more in a struggle to one virus to replace the other. There's simply a lot that we do not know at this point in time. So I'll stop there and turn it over to Melanie.
Thank you, Warner. Thank you, Deepak. Hello, everybody. I want to just take a few minutes to update you on our progress here at Gladstone on Omicron. Omicron is another all hands on deck situation here at Gladstone for us, but we feel prepared. We have 30 plus years of virology expertise here among us, especially with pandemics like HIV, Zika, and now with SARS-CoV-2. We also built specifically a BSL-3 laboratory, which is a high biosafety laboratory to handle the virus safely for SARS-CoV-2. So we are prepared to work with the real virus and to ask the really hard questions. And we have been successful in characterizing other variants before. I mean, Omicron is not the first one. We had specifically here in California, we had the threat of the so-called California variants. They were later named the Epsilon variants. This one, of course, did not take over and become a dominant threat, but was very interesting because it had similar mutations in the spike proteins like later the Delta virus. And we here at Gladstone were heavily involved in making the first observations and characterizations of these Epsilon viruses. Of course, Delta is now the most prominent virus everywhere in the world, especially here also in the US. And now comes Omicron that looks very different in its mutations. It has really mutations from all different variants. We really need to, as I said, have all hands on deck in order to get results very fast. So today, all of our virologists are working in the BSL-3 laboratory to characterize this virus. We're working both in cell cultures, but also in mice in order to ask questions about transmission and also how sick this virus is making us or can make people. And importantly, we don't do this in a vacuum. I think we are heavily connected, formed a consortium between all the BSL-3 laboratories here in the Bay Area in order to coordinate, share, and synergize instead of compete and not talk to each other. So I think the virus has been first described in a patient here in San Francisco. This virus is currently being cultured and studied by various labs here in the area. And I think we should have answers very fast. We're also in contact with our colleagues in South Africa, and will shortly receive also viruses from there in order to make sure that we can compare and get really answers to the most pressing questions very soon. And I think the most pressing questions and the experiments that are currently been done is really how well is this virus immune evasive. So if we put antiserum from or antibodies from patients who have been had COVID or have been vaccinated in its way, how will it react? Can it completely circumvent it? Will the antibodies be effective? If we put it into cell cultures, will it spread very rapidly? Or if we put it in mice, will it transmit through the air more easily than other variants? And of course, if we put it into a patient, or not in a patient, into a mouse, I think will we see enhanced or milder disease? So all these questions are currently been asked and answered, and I think from us and from others around the world. And I think hopefully in 1 or 2 weeks, we will have a much clearer picture of what this virus is going to do to us. Thank you.
Great, thank you. Thank you, Melanie, and thank you, Warner, for your initial comments. So as all of you can appreciate, this is evolving in real time, and we will know so much more, as Melanie indicated, in the next week or two as more and more data comes out. So we've got a lot of really good questions in the Q&A box, so thank you all for putting those there. I'm going to try to, many of them overlap, I'm going to try to synthesize some of those together and pose them to Warner and Melanie. And please feel free to continue to add those, and we've got a good amount of time now to have a discussion. So there are a few questions about the origin of the virus. And so let's start off by maybe talking a bit about what are our current thoughts about how this might have, so many mutations might have arisen in the virus. So, how might that have occurred? And either one of you could comment on that.
I can maybe start, and then Mrna can continue. I think what we might see here is really a convergence of two pandemics that we have. I think the virus is thought to have evolved in an immunocompromised patient, where it lingers for a long time, has been exposed to partial immunity, and then undergo selective pressure to really select out these mutations that can help it to better survive in this environment. This is one of the current models how this virus has evolved. I think an example is existing in the literature with another patient where a similar but not the same virus has arisen in this fashion. And the important takeaway message here is really that we have to make sure that both with boosters and vaccination, but also with antivirals, treat patients that have a diminished immune response very effectively in order to prevent these lingerings of viruses and this viral evolution in particular individuals. So that's one possibility.
Thanks. And what about the reports people have read about part of the common cold virus being incorporated into this?
There is, yes. I mean, it's also part of the, it's a viral component of HIV as well. So that is an adaptation that the virus has made. Maybe that confers a greater transmissibility to the virus. We don't know that that's the case yet, but it certainly is worth considering. And back to the first question that Melanie was answering, I mean, HIV, the most heavily HIV infected country in the world right now is South Africa. And so it is, the center of the bullseye for the potential confluence of two pandemics together, spinning out a particularly immunoevasive coronavirus.
It also underscores that we have to step up our efforts in getting the HIV pandemic under control in order to avoid more emergence of other variants.
That's right. And there's a few questions about the physical origin of these, and there have been reports that the Netherlands had now positive cases they can look back at some time ago that were there before we detected this even in the southern part of Africa. What are the thoughts about whether that was there as a result from spread from Africa earlier than we expected, or could it have arisen from there?
No, I would say that there's a good chance. I mean, detection is, I mean, you find the virus where it is, or you find the virus because you have a really elaborate detection system. One thing South Africa does is they have a very extensive sequencing platform in KwaZulu-Natal. And so they are sequencing like crazy. And so they picked this variant up very quickly. And it's important, as did the HIV research laboratory in Botswana. So it's important to say that, it may not be a South African or a Southern Africa problem. It's just that they detected it first. It could have come from somewhere else there. But clearly it's now being spread from there. So we don't know exactly where it first originated. And that's why the WHO moved to labeling these variants of concern with Greek letters rather than to stigmatize a particular variant as the UK variant or the Brazilian variant, so we use Greek letters.
Yeah, and as I understand, even the Spanish flu of 1918 didn't originate in Spain. It was first, caught there, but maybe even came from Missouri.
Probably a bit army barracks in the Midwest of the United States.
That's right. Now, we've talked about the emergence of the mutations that may confer an advantage for one virus versus another. And so there are a few questions about what does this concept of of one virus competing against another actually mean? And maybe you guys could talk a bit more about conceptualizing that when you talk about one out competing the other.
But there's not really actually a battle going on. I think the point is just that one is replicating faster, and then it overtakes the other one, and then it affects the next host faster than the other one, and that's why it has a spreading advantage. So I think this is the out competition, and we actually recapitulate this in the lab. We co-infect two variants in the same cell culture with and detect by sequencing which one is taking over, and we can do the same thing in mice in order to find out if there is really an advantage of one virus over the other in terms of spread and potentially transmission.
Yeah, so it's really sort of like in evolution, survival of the fittest. So if there are changes that happen to a vaccine that make it more fit than another, then over time it'll spread. But you're just seeing evolution compressed in a much shorter time frame than we usually think about evolution.
But it's also interesting because last year when we were thinking that the virus might not mutate so heavily, I think everybody was wondering what would happen if we had a selective pressure. And now we have sort of selective pressures in terms of half immunized people or fully immunized people, and the virus is continuously, those that will deal with that situation better will basically have an evolutionary benefit and will outcompete the others. So that's why we see a lot more of these variants now emerging, and because we have a lot of replication everywhere in the world still.
Now, there's a question about the San Francisco variant, whether that was, I think somebody maybe in our community is asking about whether that was sequenced in Charles Chu's lab, and has Gladstone been participating in trying to determine the origin of that?
Yes, so Charles, we actually have a phone call in half an hour, and so as I said, everybody is working very closely together here in the Bay Area, and Charles was the first one to sequence it and really made sure that this was done at I think the early morning hours, so that it was clear whether it was an Omicron case or not. We are very much involved in characterizing this virus and really finding out what it means for us now here in the community. And we're doing this, in our facility, and as it is being done currently in Stanford, in Berkeley, and in others. And we are in close contact to make sure that we're not duplicating work here.
Great.
And I might mention that this is not the only case that we have here. We're currently considering 3 other cases that have this characteristic PCR dropout, but it's not yet clear whether these are Omicron cases. So this is not going to be the last. And I think New York has also claimed that their cases were actually predating the San Francisco one. And there's, again, as Mrna said, there will be a lot of PCR, a lot of sequences being picked up at different times, and maybe from archived samples also, and we will find out that the virus did not really come first to San Francisco, but was in the country. We were just the first one to detect it, and here the PCR dropout is giving us an indication, a very handy indication for diagnostic.
Yeah, and maybe just for everybody to clarify, this PCR dropout we talked about it. The PCR test, you can think of it as measuring 2 different parts of the virus. One of them no longer works with this Omicron, but the other does. And so if you don't see both, it makes it suspicious. Products for both, it makes it suspicious that this might be Omicron, but there are other variants that also have that dropout, which is why then sequencing is required. So along the lines of this discussion we had earlier about perhaps the symptoms being not as severe. And I want to preface this question by saying that's still a big if, and we still have to determine if that's the case. But let's assume for a moment that that is the case. There are a few questions in the Q&A about whether that might spell sort of if it's more, can outcompete Delta, is less virulent and pathogenic, then could that be a good thing? And then therefore that could spell the end and begin to enter us into an endemic state. And then also a question about how does this end? How does that look? When do we know?
Well, I would say that if SARS-CoV-2 mutates itself into a live attenuated viral vaccine, that would be incredible. But my concern is that it will retain sufficient pathogenicity. I mean, it is driving people into the hospital, and some people have died apparently in Gauteng now. Although there are a lot of the cases that were picked up in the Gauteng hospital, the people came in for some other reason, and they just happened to have a nasal swab done, and they were found, so they wound up in the COVID ward. So I do think that the balance of infections is likely, the early data, but it might be milder. But the question is, would we just let this virus spread and vaccinate us all? That might be, it just depends upon how pathogenic it is.
And there's a question about children versus adult patients. And I can maybe address that. I'm in pediatrics, and I've been talking to some of my colleagues there, and there are an increasing number of children, even under the age of 5, getting hospitalized. And that number went up from 20 to 100 actually at one point. And so that, again, it's still early to tell how sick they will be, but they are getting hospitalized at a higher rate. So I think it's yet to be determined how that'll work out.
The highest proportion of infected individuals entering the hospital, I think it's like between 28 and 40. Younger, certainly younger than with the other variants that we've seen. So this virus seems to be infecting a younger overall population.
Now, we talked a bit about the PCR test. There's some questions about the antigen test. What do we expect? How do we expect the antigen test to perform with this variant?
Yeah, so the antigen test is a different principle. It's basically an antibody that is recognizing the spike protein or other proteins, and I think in the test, and so it's not the same criteria for the PCR test. The FDA has so far said that they anticipate that the antigen tests are going to hold against Omicron, and they're currently testing them individually, and will report if there's any change in this guidance.
There's a practical question here. I'm having a baby in March. Do you have any recommendations to take during the newborn phase given the current virus trends?
Get vaccinated.
Yeah, so, and this is important even for people who are pregnant. While you're pregnant, has been well studied, and it is much safer to get a vaccine while you're pregnant than to risk getting COVID while you're pregnant, where your lungs have a lot of difficulty expanding because of the upward pressure on the diaphragm, and the degree of illness in pregnant women with COVID can be really quite significant.
Plus, the vaccination of the mom during pregnancy allows the transplacental transfer of antibodies to the unborn, and then that baby is protected for a certain period of time, after birth.
There's a question about SARS-CoV-2 hiding or staying somewhere in the body like HIV. Is there any evidence of that, or is it completely cleared after infection?
That's a very interesting question. So there's some indication that maybe in some long haulers, the virus might be longer present than anticipated, especially in tissues like the gut. There's also some reports from our colleagues in Boston where they found some pieces of the virus integrated into the genome, which would then indicate that it would be present for forever or for a longer time. But these are only very short pieces, and it's still unclear whether that's really a relevant observation or not. We have looked very hard in many tissues in many samples from people who have been suffering with long COVID, One of the intriguing observations was that some patients who have long COVID improved when they got the vaccine, which would indicate that maybe the virus has been lingering and then been eliminated by the vaccine, and that improved the situation. But we have so far not been able to find any live culturable virus, in opposite to RNAs that can linger for a longer time, but they are not infectious. And I think that's sort of the difference that we have to keep in mind, because it's easy to detect the genome for a while, and that can hang out for a while, but it's much more complicated to really recover infectious virus out of for a longer time.
Great. I want to address now a couple of questions we have about immunity. So if let's talk a bit about natural infection versus vaccine-induced immunity. Mrna, what do you think of the data there? I know it's been a bit controversial.
Well, I think in terms, the early data suggests that people who were naturally infected, that their natural immunity is not that strong, that they are vulnerable, 2 to 3 times more vulnerable to Omicron than they were to, for example, Delta. Again, not huge data sets yet, but it certainly goes along with the mutations within spike that predict a far more immunoevasive phenotype. In terms of the vaccines, again, I know Israel has a case of someone who was doubly vaccinated becoming infected. I think that's going to be pretty common. The question is, how much protection will boosting give you? And I suspect more. It will certainly protect you more, but will it be perfect protection? No one knows at this point.
And we have some questions about boosters. And one is, if the Omicron is evading the immune response, how does a booster shot actually help control it?
Well, there are antibodies that bind all over the spike, and we have the kind of the principal neutralizing it, but there are ones that have effects, less prominent effects, that bind nearby, and plus the boosters are also boosting T cell immunity as well. So you're getting both the humoral response amped up at very high levels, and you're recharging the T cell response. So it's that combination that likely is providing the protection.
And I think it's pretty clear that higher numbers of antibodies are usually more protective, especially neutralizing or sterilizing, so that you don't get infected and not only not get sick. So I think a booster and increasing both your B cell and your T cell immunity, I think, is our best weapon currently against the Omicron variant.
And could you comment on what kind of response we're now seeing with the booster compared to even after the second dose in terms of antibody rise?
Oh, it's huge. At least a log more than was achieved after the second RNA dose. So it is really huge. And that's what's leading people, the vaccinologists and the others, to hope that even if that starts to decline at the same rate, it will last a lot longer because it's starting at such a much higher level. And so that's the hope, that we won't have to vaccinate every year like with the flu for the coronavirus. But stay tuned, we don't know yet.
We have to remind everybody that there are a lot of 3-shot vaccines that are very effective. And I think for SARS-CoV-2, it's very likely that we will have that this will be a 3-shot vaccine.
Agreed.
Yeah, and boosters are approved right now for 18 and older. When do you anticipate we'll be able to get to younger ages?
Soon.
Yeah, I think very soon, and hopefully by January, even initial vaccines for the under 5 clinical trials should read out and hopefully approved by February is my hope. All right. I'm not sure I'm familiar with this, but you guys might be there's a question about the concept of original antigenic sin.
But I think that is cross-reactivity as far as I'm concerned. I don't know, Warner, you might help me, but I think this is cross-presentation. So the idea is that that by an antigen that might not be exactly SARS-CoV-2, but maybe from another common cold coronavirus, you might have cross-presentation of this antigen, and you might also activate T cells that or immune cells that are effective against the SARS-CoV-2 virus, for example. Why it is a sin originally, I don't know, but as far as I'm concerned, I think it has been a lot discussed in the SARS-CoV-2 field also for children, and the original explanation why they might be more protected or less sick from the disease, because they might be exposed to other similar viruses more frequently, and that might offer some of these cross protections that are not fully clear at this point.
Great. I've got a couple of related practical questions, and that is, given everything we've talked about, even if you're vaccinated and boosted, would we attend large gatherings, say 200 plus, if everybody's vaccinated and boosted, and maybe even smaller groups of 50 or so? Or should that practices change? Should masks be on more often in those settings? What are your thoughts about that? Tough one.
I think we should not forget all the toolbox that we have. I mean, vaccination is really a very important step. And if we look back a year ago, we were in a total different situation. So I think we're all looking into the holidays, despite Omicron, not as pessimistically as it was for me a year ago. And I think the other, so masks, and I would also add to the mix the testing. I think, yes, I would feel very comfortable to go into this, into these larger gatherings if we have a larger distribution and use of our testing capabilities, also to potentially improve the antigen test so that we can trust them more. But I think going forward, we will deal with a whole toolkit of different mitigation strategies in order to give us something that looks like a normal life.
I think it's a hierarchy of decision making. I mean, the first and most important decision is the decision to get vaccinated and boosted. I think the second thing that you can do is the non-pharmaceutical interventions, the masking, et cetera. And then in terms of attending public events, I think it really matters about your environment. Here in the Bay Area, we live in a very low community load of virus, and very different, for example, than Michigan or Wisconsin right now. So in that setting, I mean, I would be more liberal in my practices about what I would do living here than if I was in a very infected part of the country.
Yeah, and along those lines, we had a few questions about testing. How would you recommend? We're not clearly doing diagnostic testing as much as some other countries, but I guess, Melanie, you mentioned one way to be using it is in anticipation of gatherings, have groups of people test uniformly.
Yes, absolutely. I think there's calculations that if we would all test daily and would only go out if we are negative, we would have no pandemic. So I think there is really strategies that we can take to minimize the risk of us walking around in a large convention asymptomatically and spreading the virus. Unfortunately, this virus is spreading asymptomatically. That is the big problem that gives it its advantage. And I think we have to pick it up early. I think the second thing that we have to do is even increase our sequencing capacity more, or develop, maybe some intermediate testing opportunities where, like the PCR dropout, where we have indications of certain variants without doing the full sequence. But I think for me, using easy at-home testing more frequently is absolutely important and will probably happen in the future. And the second one is that we need to be alert about what is circulating in our communities and everywhere, and we have to increase our sequencing capacity.
Now, we've got so many great questions in the chat room. We've got only less than 10 minutes left. I'm pretty sure I won't be able to get to all of them, but I thank you all for the questions you're asking, and I'll do my best in the time we have left. We've got a question about what do we see in terms of vaccine innovations and improvements over the next year or two? We know that there's discussion about people have already started making the mRNA vaccines to the specific variant, but what about new innovations that we might anticipate?
Well, I think we'll see protein vaccines make their entry into the vaccine arena. I think we'll see a dropout of some vaccines that have now been proven kind of in the real world situation not to be that effective. I think the RNA vaccines, they have set such a high bar. But if someone can come up with a vaccine that is far more durable in terms of its effect while retaining the same properties of high efficacy, well, that could be like Delta pushing all the other variants out. That vaccine could push out the RNA vaccines. But so far, we haven't identified that type of vaccine. But there are lots of candidates in the pipeline.
I think there's lots of stuff going on also with multiplexing, so that we're not just having one antigen, but one spike protein of one variant, but potentially multiple, so that we have a broader response in one shot. I think there's also lots of thinking about going beyond spike. The virus is consisting of 4 structural proteins that are immunogenic, and that might be very important to elicit a full and broader and more durable response that Mrna alluded to. And I think the other big thing that I think is still needs to be improved is the durability of the mRNA vaccine per se. It is still, an agent that needs to be carefully cooled in order to become active. It expires fast. I think these are things that I think are currently being worked on as we speak.
And related to the earlier question about masking and gathering, I'm sure with the holidays coming, it's also on everybody's mind about traveling. So I imagine a lot of people have made travel plans, and there's a question about this in the Q&A. What are you telling people and your friends about travel?
Tell me.
Well, I told everybody I'm scheduled to see my family in Europe in the eye of the storm currently. I'm definitely going to wait to hear more about the characterization of Omicron and getting more of an idea about it. I think in general, I think the airlines have done amazing jobs in terms of increasing their ventilation, and I think if carefully masked, I think there is a good chance that the travel remains safe. But there's also the interaction at the airport and other encounters there that should be taken into consideration currently.
My threshold for traveling domestically is I feel a little bit safer, but then not flying into a very high infection zone, but far better flying domestically than long hauls to Europe or to Asia, et cetera. So I would probably avoid international travel if I could, and be careful about where I fly domestically. Don't want to fly into a hot zone.
Yeah, and I might make a comment about masking. The type of mask matters. All masks are not created equal. And so if you're going to be in a gathering or traveling, we'd highly recommend using either an N95 or if we at Gladstone, we use a lot of the KF94 masks, but they are comfortable now and really provide you a much greater degree of protection than your average mask, and they're not expensive. So I think the type of mask matters quite a bit to protect yourself and others. So there's so many other great questions. I'm going to ask one more practical question, and I want to get to an end question. And the practical one is, if you've gotten an mRNA vaccine, mRNA vaccines, and you're getting your booster, is there any benefit to using a different mRNA? If you've got, say, the Pfizer, should you get the Moderna? Might that be better? And then we should comment on the J&J versus a repeat J&J compared to an mRNA after the J&J.
So CDC guidance is, I mean, you can mix and match. If I were getting my booster today, I'd probably go with the 50 microgram Moderna dose. And I had Pfizer the first 2 doses. Moderna just seems to be getting a little bit more durability, a little bit better antibody response. But Pfizer is excellent as well. I mean, it's a few percent better. J&J, clear benefit of boosting the first J&J with an RNA vaccine. Again, Moderna outperforms in terms of neutralizing antibodies, outperforms Pfizer by a small amount.
Yeah. Okay, so here's the question everybody wants to know. So we are now approaching a year since we first had the vaccines. So that's December 15th, maybe last year. So there is a question about how we feel about that and how we've done with that. We probably won't get to, I think, to have time to answer that, but how does this end? I think is what everybody wants to know, is how does this come to a conclusion, and what do we expect what should we expect for 2022?
Melanie, you want to start?
One of you comment. Melanie, why don't you start?
So I think first of all, for the vaccines, I think I'm still so grateful for the vaccines and so amazed that they worked out so well in how they have performed, because we still have to remind ourselves, even if we have the so-called breakthrough infections, I think we have a huge benefit in terms of keeping people out of the hospital and really drastically reducing risk of death. So I think if I look back and I look forward, I think that unfortunately, this will not all end in a bang, that 1 shot, 2 shots, or 3 shots, this is the end. I think the key is for us that that we really look globally now, and that's what Omicron has taught us. I think we will have to increase our efforts to vaccinate the world, because that will bring us a very big step closer to solving this issue. But we also have to look into our own country and have to make sure that that there is still that we convince our unvaccinated people to get vaccinated, because I think now is the moment. And if we had a 99% vaccination rate, we would definitively look differently into the future than with what we have today.
Yeah. Warner?
I would just echo many of Melanie's comments and just saying my perspective on life is so different December of this year versus like October of last year, of 2020. I do not believe that I'm going to die of this coronavirus. I don't believe my family will die of this coronavirus because they've all been vaccinated. And that is such a gift, such a reassurance. Yes, I may get infected. I might be sick for a while, but I really am confident that I'm not going to die. And that just changes my whole perspective in terms of the way I engage with people, with science, with society, et cetera. And we are in such a better place, and we could be in an even better place if we could convince the vaccine hesitant to get jabbed.
Well, thank you so much, Warner and Melanie, for your insight, and for all the participants for their wonderful questions. I'm sorry I couldn't get to all of them, but feel free to engage with us in other ways, and we're happy to answer your questions. We didn't take time today to share with you some of the great things we're doing at Gladstone on new testing, treatments, and vaccines, because we wanted to really focus on your questions and where we are today, and that's what we can anticipate going into the coming year. But I wish you all a wonderful, wonderful holiday with your families. And I think the bottom line from what you heard today is, if you're vaccinated, get boosted, see your family, be with them, and just be careful. So and hopefully 2022 will be better. Thank you
Bye.
all. Bye.